mathematical problem related to buffer solution. Let us see a problem. Let us consider this is a solution. 200 milliliter 0.25 molar acetic acid solution. We know acid dissociation constant of acetic acid is 1.8 times 10 to the power minus 5. Solution of acetic acid. We know acetic acid is a kind of weak acid, so it ionizes partially to form acetate ion and proton. In this solution, acetic acid ionizes in this way when sodium acetate salt is added to this solution. Then in this solution, salt of weak acid and strong base, sodium acetate, ionizes fully to form acetate ion and sodium ion. Now, due to common ion effect, acetate ion, for this reaction, equilibrium state moves backward direction according to La Chatelier's principle. When this reaction equilibrium position moves from right to left, then concentration of proton decreases because products convert to reactant due to the common ion effect. As a consequence, concentration of hydrogen ion decreases, and when this is 1.5 times 10 to the power minus 5 molar. In this case, to get concentration of hydrogen ion 1.5 times 10 to the power minus 5 molar, then how many grams of salt has to be added to this solution? That is, how many grams of salt? Salt has to be added. This is, we have to find how many grams of salt has to be added to this solution when concentration of hydrogen ion is 1.5 times 10 to the power minus 5 molar. This is a kind of acidic buffer solution of weak acid and its salt. So this is a kind of acidic buffer solution. Now we know Henderson-Hasselbalch equation for acidic buffer solution, pH is equal to pKa plus log concentration of salt divided by concentration of acid. Concentration of salt has to be calculated. From this equation, we can write log concentration of salt divided by concentration of acid. On the right side, we get pH minus pKa. pH minus pKa. Here pH minus log of concentration of hydrogen ion minus pKa. Equation is minus log of Ka, then minus log concentration of hydrogen ion, this 1.5 times 10 to the power minus 5 minus, here minus minus plus, log value of Ka, this 1.8 times 10 to the power minus 5. Now from this we can write log concentration of salt divided by concentration of acid on the right side minus log this equals 4.8239 minus log this equals 4.8239, then plus log this equals minus 4.7447, then from this we get 0.0792, or this log is removed from the left side, then we can get concentration of salt divided by concentration of acid. On the right side we will get antilog 0.0792, antilog this equals 1.2, this equals 1.2. Now concentration of salt is equal to 1.2 times concentration of acid, this concentration of acid 0.25, this equals 0.3, concentration of salt 0.3 molar. Now this has to be converted to gram. Now let us convert salt into gram. Concentration of salt 0.3 molar. We know salt, sodium acetate, is equal to 82 gram per mole. It means 1000 milliliter 1 molar sodium acetate is equal to 82 gram. Then 200 milliliter 0.3 molar, 200 milliliter 0.3 molar sodium acetate is equal to 82 times 200 milliliter times 0.3 molar divided by 1000 milliliter. From this we get 4.92 gram. Amount of salt that has to be added to this solution is 4.92 gram. Thank you very much.